Surface area of a cone is given with this formula, and it tells us the surface area is 300, the slant height is 15. So you've done questions before where you've had a formula and you plug numbers into it. What makes this one different is after we plug in all of the numbers, slant height is 15, and the radius, oops, just r squared. There we go. Once we plug everything in, what we're trying to solve for is r. And we have an r squared and an r. Can you see that? Sometimes with the pi's in there, it gets a little bit confusing. But this question is supposedly just as easy as if you had 5r squared plus 2r equals 10. Just the numbers are bigger. So how do we solve a quadratic equation? We move everything to one side and make it equal to 0. So I'm going to subtract the 300 to the other side. So I get 0 equals, I'm going to write it in the order that we normally write things. And once we have a quadratic equation where it's equal to 0, we have options. We can factor if possible. How's your factoring with pi? Not going to be good. Okay? So then there's either the quadratic formula or completing the square. If we use the quadratic formula, since it's an r squared, we would go r equals, not x equals. We're solving for the radius. Can you see that your b value is 15 pi? So minus 15 pi plus or minus the square root of b squared. How would you square 15 pi? Well, you go 15 times 15, and then pi times pi. It will become 225 pi squared. Might have to extend this a little bit. Minus 4. My a value is pi. My c value is negative 300. All over 2a. Now, nothing's changed from any other question that we plug things in, just our values aren't as neat to work with. That's one of the things that sometimes students struggle with in math, is when your values become not as nice to work with, like having pi in there instead of a number. You can still work this through, and we can still simplify this, and it says to the nearest hundredth of a centimeter, so we can type this into our calculator as exactly as we see it. So what we're going to do right now is we're going to take out our calculator. We're going to add the fraction button in here, so alpha y equals, create a fraction. This would definitely be on a calculator part. And then we're going to write this in, so I'm just going to make this a little bit smaller so I can, not that way. There we go. Okay, so I've got negative 15 pi. I'm going to do the plus one first. Square root 225 pi squared minus 4 bracket pi bracket negative 300. So you can type it in exactly as you have it written down. And on the bottom, I have 2 pi. I can type it in exactly as I have it written, push enter, and I get 4.81. Rounded to the nearest hundredth would be 4.82. That's with the plus sign. If I want to do the exact same thing again with the negative sign, I could either retype everything, or you can re-get what you typed before by going second, enter, or using your arrow key to highlight it. And now I'm just going to go back until I get to that plus sign. and change my plus sign to a subtract sign and get my second answer. However, for my second answer here, negative 19.8, I'm not even going to write it down, or if I do write it down, just so I remember that I did this, r equals negative 19.82, and then I'm going to put a big red X through it, because it doesn't make sense for a cone to have a negative radius. In the context of this question, we can't have a negative answer. So the quadratic formula is nice in situations where the numbers don't work out nice. Like here we're dealing with pi and 15 pi. So it's not nice to work with, but we have the use of our calculator and we have a quadratic formula where we can just plug things into, we can get an answer. Most applications of quadratic equations that happened in real life end up being not nice numbers, because real life isn't very nice mathematically. It ends up being decimals and all sorts of things. Things don't work out nice. So then the quadratic formula is really helpful in those situations. There's some questions for practice.